Hello. Now we are going to talk about shear stress and shear strain. What is the shear stress? The shear stress occurs when a shear force is applied instead of on the normal force. We have here the shear force coming down, which is perpendicular to the longitudinal direction of this beam, and this is the fixed other side, and this is coming up. This is called the shear stress. This is the fixed portion, and there will be another force, shear force, which is acting to the top in order before we have said that the sum of forces in the y direction will be equal to the 0, and then there will be shear force and accordingly shear stress. What about the shear stress value? The shear stress value will be equal to the shear force divided by the area, and the units, if we calculate it in Newton, and the area by millimeter square is becoming Pascal. So V is the shear force applied, and A is the cross-sectional area, and has the same BA unit of shear stress. This is tau, and the unit is Pascal. What about the shear strain? The shear strain, it is not at that time elongation, same like the normal force, the tension force. It is a movement of the element, and the amount is denoted by an angle alpha, and this alpha, when the angle is small, is equal to the tan of the angle, which is W by H. So consider two-dimensional square element having width of delta x and height. This is delta x and height of delta y. Shear deformation causes due to the application of shear force on the top. Actually, the upper portion gets slide and deviated W, and if we consider that the lower portion was fixed, prevented from motion, so the shape it become into rhombus, as shown at the right. Shear strain, which is called gamma, is equal to the change in right angle of the square element, alpha, and since alpha is a small angle and can be represented as tan alpha is W divided by H, then tan alpha approximately is equal to the alpha is equal to W over H, which at the end is equal to gamma. What about the units, whether it is positive, the sign convention is positive or negative? Shear strain is defined as positive. It causes the right angle of the first quadrant between the x and y to decrease. Shear strain is negative if it causes the right angle in the first quadrant to increase. The angle is measured in radian. For pure shear, as we can see, tau xy, when there is a shear here coming up, there is opposite negative, but this will cause rotational moment. So there are two other sides was created in order to keep this segment at balance. When the material is homogeneous and isotropic, then the change gamma is divided into two, gamma xy over 2 here and gamma xy over 2 there, and the angle here before it was pi over 2, so it's getting decreased by the amount of gamma xy. Here is half of the angle and here is another half, but at the end this is the final amount of the angle. Like the relation between stress and strain in the direct tension force and the curve which we have seen at the beginning of the lecture, we have a horizontal portion, and then we have plastic deformation. The linear portion before was Young's modulus when we were talking about stress and strain, but in case of the shear, the slope is called shear modulus of elasticity or the modulus of rigidity. So this is G, and here the slope equal to tau over gamma, where is gamma, we said this is the strain, and tau this is the stress, and the G. What about the relation between E and G? We can write down that G is equal to the E divided by 2 multiplied by 1 plus Moissan's ratio. We'll come to examples talking about the shear stress and strain. Thanks a lot and see you. Goodbye.